Good evening, and thank you for joining us for this live streamed presentation, The Moon, with Kelly Housley, Jay Ball, and James Gunn from the Valles Caldera National Preserve. I'm Rick Wallace with the Pajarito Environmental Education Center, or PEEC, located in Los Alamos, New Mexico. I will be the moderator for today's talk. Tonight's talk is also being recorded. We are able to offer programming at this time because of our wonderful members and donors. Kelly Housley is a park ranger at Valles Caldera National Preserve. She has worked for 8 different parks within the National Park Service, ranging from smaller park sites like Natural Bridges National Monument to more well-known parks like the Grand Canyon. She's been involved with astronomy programming for 5 years, but has been interested in the night sky since before her time in the Park Service, and she's excited to share her enthusiasm with you tonight. James Gunn is a park guide at Valles Caldera and has worked for the National Park Service since 2016. National skies have been a prominent part of all the parks he has worked at and has formed a large part of his NPS career. As an anthropologist, James likes to focus on the night skies through the lens of human exploration and belief. And last, but certainly not least, Dr. Jay Bell works as a park guide at Valles Caldera National Preserve. He has previously researched American space policy at the Clinton Presidential Library and Museum. All right, I will turn it over to you folks. Thank you.
All right, I want to thank everyone for tuning in today. We have put together a very brief talk about kind of the human exploration of the moon and what we have always observed and what we are continuing to learn about it. So I hope you guys enjoy this. I hope you learned something. And with that, I'm going to turn this over to James.
All right, so obviously tonight we are going to be talking about, as soon as I can get my thing to work, we're going to be talking about the moon. But before we launch into it, I wanted to have you guys think about a question real quick. What is it that makes you interested in the moon? I mean, obviously you guys have to have some kind of interest, otherwise you wouldn't be tuning in tonight. But what is it that makes you interested? Think about that for a second. Well, as it turns out, you guys are not the first humans to really enjoy or look at the moon. In fact, pretty much since the humans evolved, we've been taking a look at the moon. It has inspired creativity, excitement, spirituality, ingenuity, and inventiveness. The moon has fundamentally shaped who we are as humans. And yet, it is really easy to take for granted. It's up in the sky every single night, and we can easily walk by it 100 times without ever stopping to think about it. And so today, myself, Kelly, and Jay are going to be going through talking about humans and the moon, whether it be the way it has influenced our culture from ancient times or to the development of our knowledge about the moon, or even the new explorations that we are doing right now to understand more and more about it. But what I want to challenge you guys to do is to think about your own interests as we're talking about this, because what you might just find is that hearing and understanding the experiences and beliefs of others really helps us understand ourselves too. So with that challenge issued, let's go ahead and talk about some of the ways that the moon has impacted us as humans. Now, as an anthropologist, we love to argue about the idea of whether or not time is a real thing. But to some extent, that's a moot point because time has undeniably impacted the development of our civilizations. It has changed the way we work as humans. I mean, it even has biological impacts on our bodies. And perhaps unsurprisingly, one of the first ways that early agricultural communities started to look at time was by the moon, because the moon does this really convenient thing where it has a cycle that it goes through. New moon all the way to full, all the way back to new, meaning that it goes from not visible to fully visible back to not visible again. And because this process happens so regularly, people have been using it to figure out the flow of time for quite a while. In fact, the earliest lunar calendars that we know of go back to 8,000 BC. That is 10,000 years ago. And so the moon has been incredibly important to our understanding of time. And keep in mind, especially when we're talking about ancient cultures, we're not talking about the idea of hours and minutes and seconds. What we're talking about is the flow of weeks and months and years. But why would you need to know all this? I mean, why would it be important to know what time of year it is? Well, one of the big things is that it's going to help regulate agricultural production. Now, agriculture was what really allowed humans to start gathering together and developing more and more complex societies, but it's not easy to know when it's time to plant or when it's time to harvest. For instance, where I'm from, in the Mojave Desert, you can have weeks at a time in the middle of January that it's 75, 80 degrees. If you plant your crops there, though, your crops are all going to die because come February, you're going to get a couple freezing snaps and it's going to kill everything. So you need to know when it is the right time to be able to plant, when it's the right time to harvest. Also, because humans for a very, very long time, and this goes into many of us today, have used spirituality to understand their world around them, knowing what time it is tells you when it's time to do certain religious ceremonies. When is the solstice? When is the equinox? What time do I need to be making sure that I perform this ceremony? And for these cultures, for all cultures, these religious and spiritual beliefs are incredibly important to them. And so if we stop there and think about this, just these two simple things, the idea to know when to plant and when to harvest, and the idea of to know when to do particular religious ceremonies, just think about the amount of power that entails. Because understanding these cycles allows you to tell people when to do these things. In fact, if we take just a look off to the west of us over at Choco Canyon, one of the understandings of why this place developed is that it was the center of a class of people that had intimate knowledge of the sky. And Choco Canyon is a site of these massive building complexes. We're talking 5-story tall buildings, all made out of adobe architecture, but almost no one ever lived there. What archaeologists think was happening here is that there was a ruling group of priests that had a really good understanding of the night sky. They knew how to read the moon. They knew how to tell what time of year it was based off that. And in fact, they even built their buildings so that they would align with these phases of the moon. And so they were very, very well tuned in to the night sky. And this gave them the power to create a belief system that spanned over the entirety of the Four Corners region. So when we're talking about time and we're talking about the moon, it has helped people to develop power, to advance their civilization, to know how to do what they're doing better, to provide for their families more effectively. And this is just one of the ways that the moon has impacted our societies, has driven them towards what we have today. It's not just on the societal level, though, that the moon has impacted us. As it turns out, the moon also impacts us on a deeply personal level. And in fact, for over 32,000 years, we know that people have been drawing images of the moon. And the moon in art and story and literature has been incredibly important. We have here an older image of the cow, the plate in the moon, or cow and the spoon. And it goes back even farther than that and has touched people in ways that honestly sometimes are hard to express. Now, this gentleman right here is Vincent Van Gogh. He has what very well may be one of the most recognizable paintings in the entirety of the Western world, Starry, Starry Night. And if we look at this painting, it presents something very interesting, because this was one of the last paintings that Van Gogh ever did. And he used this image of the moon to represent all of the pain and sadness that he had felt in his life. So the moon gave him an outlet to be able to express these feelings. But it's not always been sadness. The moon has made people think of love. It's made people think of working as hard as they can. We've all perhaps heard the phrase shoot for the moon. It has led us to contemplate our place in the universe and in the world, to understand where we're at. And in fact, the moon has figured very prominently into many spiritual traditions. For instance, in the Baha'i faith, the moon represents the enlightenment of the prophets that God has sent down to the earth. And that's pretty powerful. It represents the sum total of spiritual knowledge for this faith. In Christian belief, the moon is often a symbol of God's protection of human beings and of the second coming of Christ. So again, we kind of combine that sense of time and spirituality, knowing when Christ will come for a second time in Christian doctrine. So from art to religion, the moon touches people very, very deeply. But perhaps one of the most important ways for us in our modern society is that the moon has also driven people to create, to want to explore. From Copernicus to Galileo to the space race, the moon has driven people to explore. Galileo, of course, created the first telescopes powerful enough to be able to do night sky observation. His knowledge directly started some of the trends in the Enlightenment that would eventually produce many of the doctrines of our modern society. And the space race is in large part responsible for how we live today. Because of this focus on getting to the moon and developing the technology necessary to do that, we have the space race to thank for things like the insulin pump, dustbusters, solar cells, and even baby formula. And this is just a few of the many, many things that the space race in particular drove to us to invent so that we could meet that goal of getting to the moon and, maybe blear the Russians' eye a little bit as we were doing so. And so the moon has not only shaped the way our cultures have advanced, it has changed the way that we live even up to today. And as we transition over to Kelly and Jay, they're going to talk about how this isn't always an easy process. Getting to know what the moon is, exploring it today, it has taken hard work. And that hard work is perhaps one of the most important things that defines us as humans, is the willingness to engage in that. So remember, as we move through this, keep asking yourself, what is it that interests you about the moon? And I am now going to turn the time over to Kelly.
So obviously, as James touched on, we've been observing and studying the moon for generations. But as our technology has improved and our observations became even more precise, our knowledge of the specific science behind the moon evolved and continues to do so today. But I don't want to say that our science, our knowledge of what the moon is, was only shaped by technological advances. Early on, a lot of astronomers, even before the invention of the telescope, were starting to learn very precise things about the moon, knowing its size in relation to the Earth, knowing its precise motions and orbital pattern, the equatorial plane of the moon compared to the Earth's tilt, knowing exactly where the moon was going to be at a given time. Kind of like what James hinted, there's a specific lunar cycle that takes between 18 to 19 years, and it took years and years and years, centuries, even after the telescope was invented, to really pin down the precise motions and where the moon was going to be when. So this required a lot of observations, a lot of naked eye observations of the moon, and just observing eclipses, those eclipses being recorded, and the fact that we today can know eclipses out for several centuries to know precisely what day and how long they'll last is really a testament to a lot of the mathematics that these astronomers were doing early on. But obviously, when we started to get more detailed images and detailed looks at the moon, our science and knowledge started evolving. So we could go beyond just looking at the orbital plane or the precise movements, and we could start really understanding the geology of the moon as well. So one thing, when you immediately look at the moon, I think the thing that's really obvious for a lot of people are these darker locations that you see. So all the mares that are, or the maria, that are labeled on the moon, and then the brighter areas, which are the highlands. These mare and highland areas were mentioned by Kepler and Galileo, but the darker areas for a long time were believed to be oceans. Kepler and Galileo, who we see both of them as very prominent, very knowledgeable gentlemen of their era, both of them assumed that these had to be oceans. So that's where the term mare comes from, that idea of there being an ocean on the moon. Now, what this actually is, these highland areas are actually the younger areas, and the maria are ancient basaltic lava flows. So those of you that think I really can't stop talking about volcanoes, you're absolutely right. So there was some lava and some movement on the moon, and that would have created these darker areas that you're seeing in these maria. Now, obviously, the advancement of technology, Galileo inventing the telescope, meant that he could start observing the moon in a lot more detail than had been done previously. Now, the popular theory at the time was that the moon was smooth, but as you can see in his drawings, these were done in 1609. And you can see that there are shadows, that he depicted shadows, and the lengths of the shadows on the moon seem to change as he observed the moon. And that to him indicated that there were mountains and craters on the moon. So this was one of the first proposals, that the moon wasn't just this round, perfect ball in the sky. It actually had dimensions and topography on it. These close observations of the moon, his observations of Venus, those were some of the things that really convinced him that the Earth orbited around the sun rather than the sun orbiting around the Earth. But really just being able to observe it, and you can see how detailed his drawings are here. You can see that he was really spending the time. I don't think I could make such beautiful drawings as he did back 400 years ago, 500 years ago. But not all close observations yielded accurate observations and theories, though. One thing that I stumbled across, which I found really fascinating, in the late 1800s, there were several astronomers, and I think this kind of speaks to our desire to find life in the universe somewhere. But there were several astronomers that were dead set that there were going to be alien civilizations found on the moon. And so in the late 1800s, William Herschel was using a pretty strong telescope that he had built to observe the moon. If you recognize the name, good for you. He's the one that discovered our 7th planet, Uranus. He never published these theories, though, the theories on the moon, but when he was looking at the very close images of the moon, what he noticed were these almost perfect circles. And to him, that was not natural. So he called them circuses, which for him, it was a structure in a circle. It's not our modern definition today. But to him, these were lunarians, people that lived on the moon, that created these perfectly round structures. And he even reasoned that the science behind it was to, because there was no atmosphere on the moon, that it would collect sunlight coming in from the perfect circle. So that was his reasoning, and he was dead set on that being true. Now, he actually believed this. There was another astronomer, actually his son, John Herschel, who an article in the New York, it was the New York Sun or the New York Post, I can't remember precisely, but in 1835, they started posting, they started creating articles, a series of 5 or 6 articles that said that John Herschel was observing the moon in such detail and such precision. He was in South Africa at the time, and he had this really high-powered telescope. They claimed that the telescope was using 42,000 times power for magnification, which I think any astronomer, anyone who uses a telescope is kind of laughing a little bit right now. But that basically means that anything on the moon, he could determine down to about 18 inches. He could see details too. So what they claimed was that he was actually witnessing Batmen and Batwomen, and he could identify different types of like trees and fauna, and there were unicorns on the moon. So this was known as the Moon Hoax. And from what I've read, it doesn't seem like a lot of people were buying into it. They started realizing as the series went along that this wasn't true. But this just goes to show how strongly people wanted to believe that we weren't alone in the universe. The one thing they did get right was that John Herschel was in South Africa using a telescope. So it just wasn't that high powered. But one of the other theories early on that stayed around for a long time was this idea of these circular patterns that William Herschel was seeing. There was a really big debate on whether they were volcanoes or craters. And for those that were arguing that it was a crater, they were kind of in the minority for a couple hundred years. A lot more astronomers were vocal about it being volcanoes, and they were kind of imagining a more geologically active world than actually was the case. Now, obviously, it's widely accepted that the majority of everything we see on the moon are actually craters rather than actual volcanoes having, erupted and then collapsed like a caldera or anything. So over the years, as our science has evolved, we've also developed these different theories as to where the moon came from. And this is a pretty common question, I think, for anyone who might go out and just casually observe the moon and you're not looking into the theories, what specifically is this coming from? So early on, one of the theories that caught on was that of fission. So the idea was that the Earth early on was rotating so quickly that a piece pulled off of it and became the moon. Now, it would have to be rotating fast enough. The argument was it would rotate on its axis once every 5 hours. So if you can imagine a day length being 5 hours, that would have to be how fast the Earth is rotating. Now, the main problem with this theory, well, a couple main problems, is that the Earth has never rotated that fast. We can find fossil evidence, specifically from coral reefs. When we look at them, we can kind of determine how fast a day used to be. And although the Earth did used to rotate faster, and the moon actually slowed our orbit down to the 24 hours that we experience now for a day, it never rotated that fast. There is also really strong evidence that we pulled from the Apollo missions and from other lunar missions, getting samples and everything, showing that the moon was really, really, really hot at one point in its past. And the fission theory doesn't quite account for that. Most proponents that were arguing for this would usually, and I guess it kind of does show that over here, the argument was that it kind of pulled off from where the Pacific Ocean was, and the Pacific Ocean seems to be younger than what the fission theory would need to be. So doesn't all quite line up, but this was one of the many prominent theories early on. Another theory was that it was captured. Either it was like stolen from Venus or it was just flying by and caught in our orbit. But one of the pictures I showed really early on actually showed a perfect ratio of the Earth to the moon, and it's a really massive size compared to any other moon in the solar system. The ratio is just really big. So again, it doesn't really account for that really hot period early on in the moon's history. It also doesn't really account for, the moon has a core, has an iron core, but it's really, really small. So if it was something captured, we would expect that core to be a little bit bigger. There's another one that basically says that we all kind of formed at the same time and condensed, and we just happened to kind of catch each other. But the common theory today is the giant impact theory. So this was first proposed all the way back in 1946, but it fell out of favor pretty quickly. It wasn't until a few decades ago that it caught on again and it became widely accepted. But the idea is that there was a huge Mars-size protoplanetary object that came in, and as the Earth was still kind of in that protoplanetary phase, this protoplanet called Theia slammed into the Earth and created this massive amount of energy. So obviously there have been lots of pieces spewing off and then recoalescing with the gravity. And this would have meant, because the energy was still really high and it was really hot, that the moon would have been a magma ocean. So we would have seen, well, we wouldn't have seen it, but if we could time travel, we would have seen a moon that looked very, very orange in the sky early on in its formation, if this theory holds true. One of the things that really helps this theory is that there is a lot of anorthosite on the moon. So that is a type of rock. We can actually find it on the Earth as well, but we have a ton of it on the moon. And really, because of how high in aluminum it is, it really only could have formed on the moon with a long period of cooling after a very short period of accretion that would have come from a really fast heating period. But there are still some unexplained features for this theory. So if you don't completely buy it, that's okay. Most astronomers are accepting it right now, but right now we don't have another theory that really will explain those oddities in the giant impact hypothesis, while also kind of explaining those that the giant impact hypothesis does explain, like the fact that we have a lot of this a similar composition of minerals, for instance. So that kind of is a point in favor of the giant impact hypothesis. But again, we don't know. There might have been another explanation that we have yet to come up with. Again, this was only widely accepted in the 1980s. So who knows what new evidence we'll find, especially when we're able to get back to the moon and get more samples back as well. But there are still a lot of unknowns. So even with our high-powered technology, even with what we've been able to do in the last several decades, there's a lot of questions that we have yet to find answers to. So, I think the first one right off the bat would be, if the giant impact theory is not how the moon formed, then where did it come from? What formed it? Again, we have the largest moon in the solar system by ratio. So, how did that happen? I mean, it's something clearly unique and special, but we don't have another theory for that. Specific features can also yield some of these questions as well. This is Oceanus Priscillarum, which is the Sea of Storms. And this is the largest mare on the surface of the moon. And we're not quite sure where it came from, because we don't really see a rim around it to indicate that it was a crater. So it's very possible that it was an early crater and maybe the volcanism kind of got rid of the rim, or maybe it was a contraction as the moon was cooling. You can kind of see these ridges right here. Maybe that occurred when the moon was cooling off and it shrunk a little bit. We don't know. We don't know where that came from. So there are even specifics on the moon that we have yet to figure out. So with the far side, we have learned a lot about it in the past few decades, but are we going to be able to get samples back? We might have more questions over there as well. There's also water on the moon, so there is ice, specifically in the polar regions and permanently shadowed areas. But is there more than we think there is? Is there water underneath the surface of the moon? We don't know. So these are all kind of questions that we have yet to answer, and there are some that we haven't asked yet, and I don't think a lot of people have thought to ask them. So we'll see what the future brings. And then there are lava caves on the moon. And so the idea of trying to explore them and seeing if it's possible for human habitation that would help protect us from radiation, just trying to navigate, trying to get something there to explore these lava tubes is a lot harder than just sending a drone in there. So who knows what we'll end up finding in the future. So I guess the final question would be, what next? Only really through continuous observation and study can we find these answers to these questions. And in the past few decades, we've really pushed that spirit of exploration even further. So what we've begun to learn and what challenges we have faced in our ever-ending pursuit of knowledge, I will turn that over to Jay and let him explain.
Thanks, Kelly. Hello. Hi there, everyone. It's great to follow James and Kelly. And what I'd like to do this evening is just to kind of informally talk a little bit about, pick up the theme of Kelly's theme of how we go about getting data about the moon, a little bit about the history of probes and the future of landings. So with that in mind, let me share my screen with you. Really, the focus of my chat with you this evening is to kind of catch you up on the Lunar Reconnaissance Orbiter, which was launched in 2009 and is still in orbit around the moon, and we're probably going to get another 7 or 8 years of service out of it. This platform has singularly produced more data about the moon than all other scientific instruments that have been sent to this satellite. And it's still producing exciting research. So what I'd like to do is talk a little bit about what the LRO is teaching us, and to give you a little bit of backstory behind the LRO. So with that in mind, and by the way, if you want to sound NASA hip, you have to say LRO kind of as quickly as you can to get in the spirit of things. This is actually the first image of the moon taken by a Soviet Luna probe from 1959. And you can imagine that we've come a long way since these first images. The first probes, there was kind of a probe race to the moon in the late 1950s. And you may remember from your space race history that the Soviet Union was actually ahead of the game early on. And some of the first best science about the moon came from the Luna probes, which generally had more success than its American counterpart, the Ranger series. And most of these probes were either designed to orbit the moon, but the majority of them were designed to crash into the moon. And as it approached the moon, it would be taking a series of images and then beaming those back until it went to an all gray screen after it crashed. But even given that the Ranger series wasn't trying to land softly on the moon, even crashing into the moon proved difficult. So one of the things that is probably worth recalling is that the whole science and technology of landing probes on another celestial body is extremely difficult. And there was a lot of trial and error, especially early on. Now, the focus of the American program actually early on was on the space race. And the space race was about landing people on the moon as soon as possible. And in many ways, science took a back seat to the exploration part of this, the drama of that. And so the second series of probes that we launched to the moon from the United States was the Surveyor Series, which was primarily designed to test out the feasibility of landing softly on the moon and to answer one of the big questions that we had, which is, how deep is the regolith? Now, regolith is a term referring to that coating of dust that covers much of the surface of the moon. And we simply didn't know how deep it was and if our landers would be able to land safely in it. So the Surveyor Series, which was more successful than Ranger, was primarily designed to basically reconnaissance the landing of the Apollo moon missions. And it did not provide us with just a lot of science about the moon, other than telling us some important things about the regolith. So the surveyors, mid-60s, they are pioneering, they are testing out the landing sites for the Apollo missions. In fact, Apollo 12, which we see right here, landed within just a few hundred yards of one of the Surveyor missions. And it's with the Apollo missions that we actually begin to get some really exciting new science about the moon. We brought back about 900 pounds of moon rocks, and the rocks from the moon told us several things. I mean, one, helped us to date the moon somewhere between, where are my notes here? About 3.5 to 5 billion years old. And the Genesis rock, which was recovered, was the oldest rock that was found from the moon missions. So the Apollo missions, bringing back rocks, being studied, useful. But one of the things that we probably know about the Apollo program is that the Apollo missions early on were focused on exploration. The later missions were more focused on science, and it was precisely those later missions that were cut. So we had 3 or 4 strongly dedicated science missions, and then the projected Apollo later missions that would have fully expanded on that geological research were cut, partly because of the expense and also partly because there was a waning interest of the American public in the exploration of the moon. And it's one of the, and this is a close-up of the Genesis rock. And it's one of the curious things about our relationship with the moon is that after the initial great excitement over the Apollo landings, the excitement about the moon cooled off. And NASA became more focused on getting landers to Mars. And I would probably say that many of you know many more of the names of the landers on Mars than probably you do of many of the subsequent moon missions. Mars became the focus, and it was quite successful. So the Viking 1 and 2 landers, which landed in 1976, this is pictured here with the scientist Carl Sagan, made successful soft landings on Mars and gave us valuable images and information about the composition of Mars, and really set the tone for all the success that we have had on Mars. So the moon, after the excitement of the 60s, begins to take a backseat to Mars. And in fact, as NASA is going forward with its plans in the 1970s, the focus is much more on low Earth orbit operations and the space shuttle. And so the space shuttle operations then dominate the mission of NASA and its exploration mission for the 70s and 80s and into the 90s. And it's only when we get into the 2000s where we begin to have, certainly after Challenger, which is 1986, but after Columbia, the Columbia disaster, that the decision is made to shut down the space shuttle program. And the question becomes, what next? What does NASA do next? And NASA under the Bush administration, or the George W. Bush administration, said what we need to do is we need to get back in the business of planetary exploration. And it's in this environment in which the moon comes back into focus. NASA takes the view that we need to go back to the moon. We need to establish bases on the moon. We need to find resources on the moon and see the moon as a stepping stone to exploring the solar system. And so what do you need in terms of, and it's the Artemis program is the name for the landing program, but really there's a spirit of going back to Surveyor and saying we need more new science about the moon. And we've got this amazing new technology that we've been testing out on Mars. We should be doing the same with the moon. So in 2009, we launched the Lunar Reconnaissance Orbiter, which is an extraordinarily sophisticated satellite of the moon which is going to provide us not only with information about possible landing sites, but it has a whole host of other sensors and components that are going to give us a lot of primary science about the moon. And I've got here a list that you're seeing of a number of the instruments on the LRO. Measuring radiation. So if you're going to have long-term habitation on the moon, you need to know how much radiation our astronauts are going to experience. And if there are pockets or places within craters on the moon where a moon base might be sheltered from radiation, solar wind, and other types of radiation hazards. I would mention that the mapping project and the Lunar Orbiter Laser Altimeter, known as LOLA, has provided us with 3D topographic maps of about 99% of the moon now, down to about 100 meters in terms of detail. And these have been released to the public. You can go onto the NASA website and tour the moon in extraordinary detail. Of course, the LRO has amazing camera equipment, so we're going to look at some images here in a moment. And also the miniature radio frequency radar is also about providing the most precise and particularly precise measurements of the depth and composition of craters. And we're really interested in those craters on the South Pole, where all the evidence is that there's a great deal of frozen water, which will be very important. L-Cross was a piggyback probe on the LRO, and you may remember this, which was actually detached from the LRO and crashed into the Cabeus crater in the South Pole. And when it crashed, it sent up a spew of debris, which then the probe was able to measure for its water content. And lo and behold, there looks to be quite a bit of frozen water in the South Pole of the moon. So all this is super important for going back to the moon and kind of resources that the moon might provide for permanent habitation and also future missions. Now, here's some images from the camera of the LRO. And it's just, as you would imagine, in 2009, the level of detail that is able to be achieved by these instruments is just extraordinary. And again, you can go onto the nasa.gov website and you can go through thousands of these images with extraordinary detail. I'm particularly excited by this photo here, which is in the inside of the crater Tycho. It's just a beauty. And you can see the level of detail. And this is also a crater that we're very interested in exploring the interior of. And I couldn't resist just some of the beautiful images produced by the LRO. So you may remember some of the beautiful Apollo mission photos of the Earthrise being a famous one, credited by the former Senator Vice President Al Gore as really changing our whole consciousness of what it means to be on Earth, to be Earthlings. And I'm circling back to James's point here, way in which the most advanced scientific technologies affects our cultural worldview and practices. And this image, if you haven't seen it before, is just beautiful and really shows the fragility and the beauty of our planet here in space. But, you know, there are other instruments on board. And I wanted to just give you a sense, it's not just what we see on the surface, but it's also the subsurface images that these probes can produce that are producing some of the most important science. And probably, again, one of the most important things we're learning about is water on the moon. And so here is an image of the South Pole and sites that look to have large quantities of frozen water. So you can imagine when we do go back to the moon, either with more probes, with astronauts, we're going to be focusing a lot on that South Polar region. And there's also the far side of the moon. And guess what? The People's Republic of China has beaten us all to the far side of the moon. In 2019, they landed the Chang'e 4 lander, and it was the first soft landing on the dark side of the moon. And there are lots of reasons to be excited about the far side of the moon. So what I'd like to do, wrapping up, is to summarize sort of the major scientific discoveries that the LRO has produced. For one thing, the LRO has proved that actually the moon is shrinking. It's puckering and it's also quaking more than we thought. So this has to do in part with its gravitational relationship with the Earth. So the moon is shrinking and quaking. The LRO has helped us discover that. The LRO has also helped us discover that there's more that volcanic activity has been more recent on the moon than we previously thought. There were significant debates about that. The LRO has helped us see that the far side of the moon is older than we thought, and it's older in some that the exposed rock of the far side of the moon is older than what we see on the near side, which is the only side that we see from Earth. These craters, as we are able to look into them with these instruments, provides us with a much greater detailed timeline about the history of the solar system itself. And so each one of these craters tells a different story about the solar system. So that's something, as we think about going back to the moon in force, that's going to be very exciting. We also know that that South Polar region is a lot colder than we thought. In fact, some of those craters may be some of the coldest places in the solar system that we know of, which tells us that the possibility of large deposits of ice that are going to be there permanently is a very strong possibility. And I guess maybe the last thing I can say is that the moon is just a lot more dynamic than we thought before. The LRO has helped us show that it's more dynamic. It can look like the most static place in the world as you look up at it in the sky, but actually a lot is going on there, and it's going to be a trip, and particularly all of the mysteries on the far side of the moon. There's so much more original done there. That's the big question that I would leave you all with is, should we go back to the moon? You know, I mean, we think about all of the difficulties that we have on planet Earth. We think about all of the challenges that we face, the strains on our resources. Do we want to be engaged in the moon race? Is the science worth it, important? And as you know, we're actively right now, we've got several different corporate entities that are testing out possible designs to go back to the moon. And so there were these debates in the 1960s about should we be going to the moon when there was a war on poverty and a war in Vietnam and world hunger. And many of these same difficulties of the 60s have circled back to our present moment. And so this is a real interesting public debate. Maybe we're not debating it enough, but I encourage you all to plug into this debate. You are citizens of this country. You've got an opinion about it. And we are very much in a moon race at this point, which is exciting and challenging. And if we go back to the moon in force, as current plans suggest, we're going to have a lot of brand new science about exploration and about what it would be like to live and work permanently on the moon, which is maybe a little bit exciting to contemplate. So that is my presentation, and I look forward to any questions that you have. Thank you very much.
So I want to thank you guys all for tuning in, and we are happy to take any questions that you have. But the final thought I will leave you with is just to encourage you all to go out and look at the moon. I don't think we appreciate it enough in our day and age. So go out and make your own observations, make your own drawings, and look up some really awesome pictures of the moon as well, because it's a pretty special place. So thank you.
Great, thank you very much to all of you, Kelly, Jay, and James. We do have some questions. I guess at this point, what I'd suggest is that we go ahead and ask you folks to turn your videos on, and then we'll ask some questions, and whoever thinks that the question is most appropriate for them or would like to answer can jump in and start answering some of these questions. First of all, Galen noted that Bandelier is having a full moon public astronomy event on Sunday night. So some of our folks may want to look on the Bandelier website and see what kind of activities are going on and the schedule for that. So again, that's at Bandelier on Sunday night. Lisa,
I can chime in real quick on that.
Yeah, go ahead, Kelly.
So I know that they're requiring registration, or at least a reservation. I think you just need to call the number. And from what I have gathered from talking to the park rangers there, it's talk. but they should be doing it this month and next month as well. So keep an eye on their website because they've got the dates on there. And it's a great opportunity to learn a little bit more about the moon. So, yeah.
Great, thank you. Okay, Lisa asks, what is, well, tell us something about the composition of the moon's atmosphere. Does it have some remnant of an atmosphere, and what is it like?
So I can take this one. So the moon doesn't actually have an atmosphere. So that's part of the reason why why when we're looking at the moon, we see certain craters that are a little darker than others. That comes from what we would call space weathering. If the moon had an atmosphere, then it would be protected from that. So with us on Earth, you know, we're protected from some meteors as they come down because of our atmosphere, but we're also protected from space weathering because of that as well. So if you look at the moon, what's really cool about that is the lighter craters are the newer ones or the younger ones. And you can kind of see ejecta coming from the craters laying on top of older craters. And that's part of the reason why they figured out, okay, the brighter ones are the younger ones, because they're seeing the bright rays coming off of those craters over the darker colors from the space weathering of the older craters.
All right, interesting. Speaking of the craters, any ideas on how frequently the moon is impacted by meteors or asteroids or something like that? For example, large asteroids.
I don't know, Jay might be a better one to respond on this. You can see a lot more impacts on the far side of the moon, which to me kind of, I kind of view the moon as like this shield for us, because if the moon wasn't there, then we would be getting the impacts from that. But maybe Jay has a better idea, since LRO might have actually given us details on that.
Yeah, thank you, Kelly. LRO, one of the exciting things that LRO is doing is that it's actually, because it's in maintaining orbit, as the moon is getting impacted by asteroids, it's able to take before and after shots. So in the year 2013, for example, there was a flash that was actually visible from Earth. That's how large an impact it was. And LRO was able to basically analyze that through before and after photography and analysis. Now, in terms of the number of impacts, I can't really answer that, but I know that LRO is actively monitoring it. And with each impact, it's actually getting new data about the sites of those impacts, and also something about the composition of the asteroids that are striking it. So it's one of the things, another thing that LRO is doing.
Sounds useful. I would imagine that the number of impacts on the moon might be similar to the impacts on the Earth. It doesn't have quite the Earth's gravitational attraction, so there might be a little bit of a difference there. And clearly, it's a smaller target. But roughly, you know, many of the meteors that we see streaming through the Earth's atmosphere or going through the Earth or to the Earth would, I would think, also, you know, similar number would impact the Earth, scaled by the size of the moon, scaled by the size of the moon as a target. Let's see. I had a question about this too. When did the most recent volcano erupt on the moon? I think, Jay, was it you who said that we found out that there was volcanic activity more recently than originally expected? When was the most recent volcano?
Can you give me the Jeopardy show theme song for a moment? I'm double checking that for you. I'm going to give you and everyone the best possible information.
Okay. While Jay's looking that one up, I have a related question if anyone wants to try that, and that is, what are the major differences between the far side of the moon, the part that we don't see, and the part that is more visible to us, what we call the near side of the moon. Clearly, the near side has the large maria and volcanic flows and things. Why would we have those predominantly on one side of the moon than the other, especially if the other side is older than the side near us?
Yeah, so I can answer that. So the theory is, and this again could be completely wrong once we get more science, but the theory is that the crust on the far side was thicker. So when impacts hit, the lava had a harder time coming through the crust. So that's why we see Maria on the near side versus the far side. You also see more impact craters on the far side. So when you look at it, it just kind of looks like this really pockmarked image. And I'd actually shown an image of from the LRO that I found as my last slide. And it was really interesting because the Maria looked really, really small when you just have the whole map of the moon out. But the backside is really, it's kind of bright, but it's also got just tons and tons of craters. One of those craters, which Jay was kind of talking about, the South Pole, but the South Pole Atkin Basin is one of the largest craters in the solar system. It's, and when I found this out, it was in kilometers, so I never did the conversion. So if you guys want to do this, it was about 2,500 kilometers in diameter. So it's just this massive basin in kind of the South Pole, part of the South Pole, but kind of going up towards the middle of the moon as well. But then there are craters inside that as well. So it's just very pockmarked. And to me, I think that's why I imagine the moon as like our shield as it's orbiting around us, because you see all these impacts that could have reached us, but they hit the moon instead. So.
Okay. Yeah, that's really interesting. Meteor Crater, I believe, in Arizona, we think of as this huge, well-preserved crater. If anyone has ever been to see that, it's quite impressive at standing out in the middle of this empty area. But it's only 1 mile in diameter, whereas this one you're talking about 1,500 to 2,000 miles in diameter. That's really different from this one that we think is huge on the Earth. So that's pretty impressive. You mentioned the crust might be thicker on the far side, which would make it less susceptible to volcanic eruptions. Any thoughts about why the crust is thicker on the far side?
I don't know if there's any theories about it out there. It might, selenographers might essentially be arguing that because of the giant impact hypothesis, maybe there was a thicker crust as it reformed, but why it would be thicker on one side versus the other, I honestly don't know.
That's interesting. We'll have to do some research, see if we can figure that out.
Yeah.
Jay, did you come up with a date for a volcano yet?
Yeah, so the LRO has suggested that there was volcanic activity within the last 50 million years, which is a lot more recent than had been believed before.
I thought it would be billions of years. Wow.
Exactly. So that's really recent by comparison. Yep.
Amazing. Interesting. Okay. Another question. What is the best way to observe the moon? What type of equipment would be needed for a beginner to observe the moon?
So I'm just going to start off by saying your eyes, because I'm sarcastic. But no, no, honestly, I think that's the best way to start off, is to just go out there and get familiar with the moon. Once you start observing it, you could even, I'm a terrible artist, but I will draw it. And my first images of the moon, I probably wouldn't recognize as a circle even, but trying to just capture like the different just looking up, and I think kind of what James was talking about early on, cultures for generations and generations have just gone up and looked at the moon, trying to find the rabbit in the moon or the man in the moon or whatever. I think can be a fun activity in and of itself. But then once you get past that, so once you're kind of used to seeing the moon and getting a handle on its phases and what it looks like, binoculars are a really good tool. I have really unsteady hands, so I know that's really hard. So you can actually find tripods for binoculars if you would like. If you get a telescope, you actually don't want, unless you want to observe some of the craters really close in, you don't want a super high powered magnification. Because to me, when I started observing the moon, I wanted to see the whole thing. And the best time to observe the moon, if you're going to use binoculars or a telescope, is actually not at the full moon, believe it or not. So you'll want to go out there and observe around first quarter or the crescent, or actually any day leading up to the full moon, because as that line is changing and creating that first quarter and then that waxing gibbous, the shadows on the craters are changing as well. So when you're looking at the full moon through a telescope, the craters and all the mountains and everything get washed out and you don't see the topography as well. Whereas if you're looking at a crescent moon or gibbous or a quarter moon, you can look right at that edge and you can see a lot of detail in the craters. And it's a really remarkable thing. So I would start off just by naked eye stargazing, because I think that can be of benefit. But once you get to the point you're like, yeah, I want to see those craters, then definitely binoculars or even a low power telescope will do the job. So
Great, excellent ideas. All right, what does anyone know, this is a little bit off the topic, but it's relevant. Anyone know what the status of the Valles Caldera's application for dark skies certification is? And is there any opportunity for moon viewing from the Valles Caldera?
So we have achieved dark sky status earlier this year, actually, over the winter. Unfortunately, we don't have any scheduled in-person events at this time. If we do offer some before the end of the season, before it gets cold, we will definitely put that on our website, on our calendar, on Facebook. We'll advertise for you guys. But we're hoping to definitely get back in the swing of things next year. I've participated in a lot of like moon hikes, and I think they can be really beneficial. So even if we are not able to offer any in-person events in the next few months, what I will give a plug to is in October, there's International Observe the Moon Night. So you could go up to Valles Caldera, you could use one of the pullouts, you could just go out in your own backyard and observe the moon and take part in something that is done across the world, and know that you're looking up just like citizens of lots of other countries are. So that's, I want to say it's October 16th. It's a Saturday, but if you just type International Observe the Moon Night, that'll come up. So
good to know about. All right. I guess the moon is so bright, you don't really need to have a super dark sight like you might for nebulae and galaxies and deep sky objects. Even around town here, if you have some binoculars or a small telescope, you can do quite a bit of moon observing. Which reminds me, by the way, you were talking about sketching the moon. And I don't know how many of the people in our audience saw the talk that Akana Peck and participated in. She and Dave gave a talk on the moon quite some time ago now, in the last maybe a year or so ago. And maybe it was even before the pandemic started. And she talked a lot about sketching astronomical things, and she has some incredible sketches. So that it's really fun to look at actual sketches of things like the moon. Let's go on to the next one. Let's see. Jay said the moon was shrinking. Russell's question is, how fast is it shrinking, and what is making it shrink?
Well, thanks. That's a great question. Actually, it looks like, for one thing, that the moon is still cooling off. So that's one thing that LRO has been able to detect. And also its relationship to Earth's gravitational field is also having a shrinking and puckering effect. So the moon zone continuing to cool off, and then the continued stress of the Earth's gravitational force. Those are the two main factors that are producing the shrinking and the puckering.
Okay. Ken asks, I've read the moon is slowly drifting away from the Earth. Is our gravitational pull weakening?
Sorry, I was about to talk while still muted, so the typical Zoom problem. But yeah, so it is slowly going away, and we did verify that actually through the Apollo missions. They left a reflector on the moon's surface, and so we can actually measure that. It is not moving away at any speed that we will be able to really detect. It's anywhere from about 3 centimeters to an inch a year. But the main reason it's going away, it's not the lack of gravitational pull from the Earth, but it's basically we are exerting a gravitational pull on the moon, and the moon is exerting one on us. And as we're slowing each other down, so we're slowing down to 24 hours a day, and we'll eventually slow down even further because the moon has its effect on us. The moon has slowed down as well, so that it's now tidally locked. As we're all familiar with, the far side is never seen, so that means it just always faces us. But that inertia needs to go somewhere, so it's also kind of pushing the moon away just slightly. So it's not really because our gravity is weakening, it's just because of the Earth-Moon system, like the way the bodies interact with each other. I don't know if that makes any sense.
Yeah, it does make sense to me. Okay, let me ask another physics question, and I have a question for James that's more related to sociology, I guess. But first, the physics question. Galen asks, what about gravity anomaly differences between the far side and the near side? Is there more mass concentrated on the near side so that the mutual gravitational attraction would orient the moon such that the heavier side lies farther away from us, or rather lies toward us because of greater gravitational attraction? Anyone aware of those kinds of studies?
I will be the first to say I am not sure. I think that's beyond my my source of study. But if anyone else wants to chime in, I'd be happy to let you.
Yeah, anyone else want to take a stab at that one?
That's way beyond my purview.
Galen, if you're interested, I'm not sure how to unmute your microphone, but if you have more to add to that, if you send me a note in the chat, I'll see if I can let you say a few words about that. In the meantime, question for James. You were talking about the effect of the moon on lots of social systems, religious systems, calendars, agricultural systems, all sorts of human endeavors. There are many more modern discussions about the effect of the moon on people. For example, that during a full moon, the moon exerts all sorts of influences on people to make them do crazy, weird things, and that animals go crazy during a full moon. May not really turn into werewolves, but do something very strange. And I've even had a friend who's a policeman said they see more criminals coming through the legal system being arrested during full moons. Any thoughts on those?
Yeah, it's a really interesting phenomenon because if you look at it statistically, there's no increase. ERs don't see an increase. Crime doesn't increase during the full moon, but this idea is really prevalent. And at least for Western cultures, this goes back a very long way. And we can see things in medieval Europe that are talking about how the moon makes people go crazy. The idea of moon madness, werewolves that you mentioned. So these ideas go back very, very far. And the really cool thing about this is that it shows us how deeply cultural ideas can impact even the way we see reality. Because I'm sure you could find many, many, many policemen who would tell you, yeah, crime is worse on a full moon, or many people who work in ERs that are like, yeah, we see a lot more things happening on full moons. And yet statistically, this isn't true. This is a cultural idea that actually completely changes the way that we look at the world and understand the world around us. So it's actually a really cool phenomenon, a really cool idea.
I heard one time about a study where they looked at um, the rates of criminal activity, for example, and apprehensions when during full moons, and they compared when it was cloudy and when it was not cloudy. And what they found is that when it was not cloudy, they did have higher crime rates and higher arrest rates. When it was cloudy, even though it was a full moon, they did not. And the conclusion was that it was the fact that there was more light during a full moon that criminals could see better, so they would try to do things. Police could see them, so they got arrested more. And so it had to do more with the light than it did with the actual moon itself. But for what it's worth, let's see. We have a few more questions coming in. Is the moon, Ken asks, is the moon protected from exploitation? With corporate exploration, are there limits to ownership, development, and mining?
So Jay might know the specific year of this, but there was a treaty that was signed. And I want to say it was in the 70s that said that no country can own the moon. Now, you'll notice that doesn't, because corporations aren't countries. So over the decades, corporations have like tried to exploit that and Jay, if I'm getting the year wrong, please let me know. But I want to say it was in the 80s. There was a corporation that was like selling moon plots to people. And obviously it didn't go anywhere, but it's, I think, an interesting question, especially with what Jay brought up, because we are seeing more private exploration. And that wasn't the case when that treaty was originally signed. It was all run through the countries. So in theory, no country can own anything in space. So like the US can't go up there and be like, we want to make the Apollo landing site a national park, because that would be owned by the government. So that would be problematic. But in terms of like a private company going up there and saying that, I think people would still have an issue with that. But if there's any illegalities with that, I don't know for sure. There might be soon. I don't know.
Yeah, I can imagine that private companies, if they're talking about using the moon as a base to from which to launch further exploration into the solar system, and we have a lot of private companies involved, the only way to make that economically feasible, I would imagine, would be to find some way of making a profit from that, and that would entail mining or somehow accessing those resources. As people are talking about mining asteroids. So this outer space treaty you were talking about may prevent government ownership, but I would imagine there is some loophole that would allow the equivalent of mineral rights that we have here on the Earth, where you don't own the land, but you have the rights to extract minerals or something like that, or minerals may be water and oxygen, but whatever it may be. I'm sure people are thinking about that. Anyone else? Jay, do you have any thoughts on that?
Well, Kelly's right about the treaties. 1979 was sort of the latest of these treaties, as you were saying. However, the provisions are very weak. So the idea that you thought maritime law was weak on Earth, basically the legal status of the moon, if someone wants to be a lunar lawyer, there's a future in that. So if anyone any of you thinking about a young and a future career, look to the skies.
That was a really, really excellent question. Thank you, Ken. Let's see. Jay did find some information about the gravity differential on the far side of the moon. Let me see if I can copy his, he was able to send to everyone. So if you look in the chat, you will see a link that Jay sent that's related to gravity differential on the far side of the moon. So Galen points out that this study that I mentioned about the full moons and the cloudy versus the clear nights, such that more light meant more crime, he says is more evidence that light does not decrease crime, and therefore we should moderate our light so that we have less light pollution and stop having these huge floodlights lighting up everything in the name of security, because more light does not necessarily mean you're more secure. So that was an interesting observation. Okay, so if you want to click on that link that Jay sent out, you might want to do that fairly quickly, because that seems to be all the questions that we have at the moment. So I think I'll wrap things up. Again, Kelly, Jay, and James, thank you so much for sharing with us tonight. And next week, we will not have our regular Friday night astronomy show, but do join PEEC for two fun events. We have the Bear Dinner, and that's particularly on Saturday, I believe. And the Werner Herzog movie Grizzly Man will be shown on Friday night in the planetarium, I believe, and a free family-oriented bear festival, here we go, on Saturday from 10 a.m. to 2 p.m. There will also be some planetarium shows, by the way, live planetarium shows in conjunction with that, focusing on the Ursa Major and Ursa Minor, the Big Bear and the Little Bear constellations in the sky. Find out more information and register for the dinner and the movie at the PEEC website, peaknature.org. Thank you again to all of our speakers, and thank you to all of the participants, and have a good evening.